Hi, everybody. Welcome. I should let you know because a few people can't be here that I'm going to be recording. All right, let's get going. If anyone has a question, feel free to get started. Yeah, just shout it out, Ishu.
All right. So on page or on 2.4, there's a problem number 6.
On
Or let me just get. There's
2.4,
like where
go ahead. Sorry.
number 6.
Yeah.
Yeah, where they give you like a solution. They give you a solution and you're supposed to find out or come up with like an original inequality.
Yeah.
Um,
Is this in the hodgepodge?
yeah.
Okay,
Yeah,
I'll
this is in the hodgepodge.
from back 2.4. Okay, let me
Yeah.
pull it up. Um, And I'm gonna make sure that you guys can see my screen after I pull it up. All right, can you see that issue?
Yeah.
Okay, so number, and I think I know which one you're talking about. Scroll down to number 6, you said?
Yeah.
Okay. Okay, yeah.
Um, so I got some answers, but I don't know like whether or not how can you tell whether or not there should be whether or not it should be an odd exponent versus an even exponent.
Yeah. So the way to approach these is to first the first thing I would do is put these numbers on a sign chart. And so when you put them on the sign chart, and the nice thing when you're given a solution, it's given from left to right, lowest to highest. So that kind of helps you and you don't have to like reorder things. So the first step again is me putting these things on a sign chart. And then oop, I put 7 twice, sorry. And then did I get everything? 1, 2, 3, 4, 5. Yeah. And then you've got some brackets and parentheses here. So what is that telling you on the sign chart? What should
Sorry,
I
mute
do?
button was working. Like certain like turning points are exclusive and exclusive
Yeah,
to
exactly. So I would put the brackets, I'd put filled in circles. And I think it's just -1 and 3 in this case. And the others I'd put
yeah.
open circles. And then the next step is you want to decide, do you want to do an inequality that you're looking for greater than or equal to, or do you want to do an inequality less than or equal to? And the truth is, it doesn't matter. Just pick one. Um, and what do you think?
Let's just do greater than equal to. I feel like that one's a little bit easier.
Okay, so greater than or equal to. All right. And so that means what I've given you on terms of the sign chart, since we were finding things that are greater than or equal to 0, the solution should be the positive sections, right?
Hmm.
Okay. So then I'm actually going to mark that on my chart. So that should be a plus. 5 to 7 should be a plus. 3 to 5 should be a plus. And then -4 to -1 should be a plus. And everything else should be minus. Do you agree with that?
Yeah.
Great. Okay, so now I'm going to build my inequality, and anything with an open circle is going to go in the denominator. So I'm going to put x plus 4, and we'll talk about the exponents after I just put these various factors on my sign chart, x minus 5 and x minus 7, and then in the numerator, x plus 1 and x minus 3. Does that feel okay so
Yeah.
far? Okay, so
Yeah.
now
Yeah.
remember when we build a sign chart, when it's not changing, when something's raised to an even exponent, that means it's not going to change sign when we go on both sides of that number. So I'm looking at my sign chart, and what numbers is it not alternating signs across?
Uh, five. Oh, 5 and 7. Okay, that's why you put.
Exactly. So those would be the two factors that are raised to even powers. Everything else, if it
Oh,
oscillates, it means that it's going to change sign across that particular number that comes from that factor. Um, so we're not done though, because here's what we have to make sure. We have to make sure
okay.
that, go ahead, sorry.
Wait, do you have to like actually like solve it, right? To just double check
Yeah, just double
your.
check. Like if you plug in a value greater than 7, are we in fact going to get something positive?
Yeah. Well, actually, one second. Yeah, we should be.
Yeah,
Yeah,
so if
yeah,
you
we
plug
should be
in
getting
like
something
8, we
positive.
should get positive, right?
Yeah.
Okay, so that's the last thing you want to double check because sometimes it could be the case if we put in less than or equal to as our solution, or you just want to make sure. What if it hadn't come out positive? What would we do instead?
Then we would have to rework like
Well, we
our
could have just put
current
a negative
equation.
in. We could have just put a negative in front to make sure
But
it starts off properly. Because we would just need to flip the
oh,
sign
okay.
of everything, but in this case, it started
Mhm.
off fine. So
Okay.
we were okay with that. So it's really once you build that sign chart, you deciding if it's not changing sign across a number, then you put a positive, an even rather or odd exponent with it.
Great. Thank you.
Yeah. All right, Devin, you go.
Okay, on section 2.7c,
Yeah.
on question 4, I had a question.
Yeah.
So in the answer key, you like it's like one of those ones where you have two planes and you have to figure out the
Yes.
intersection.
Yes.
And what you did was you isolated the y, but I isolated the z.
That's fine.
So I got my or sorry, you isolated yeah. So my points were 11 minus 5k over 3, comma
Okay.
k, comma negative 4k plus 8 over 2. So what I was wondering was like in the
Yeah.
B part of the problem, how do I figure out like what the coefficient of y should be and what the number on the other side should be when I have like the k over a fraction?
Okay, so tell me, so you still should have gotten three different, so tell me what your solution is. So first, just so everyone's on the same page with this problem. So this was on a test, maybe 2 years ago, I put this on the test. It wasn't last year. So needing to know that two planes, how did two planes have to intersect? If they intersect, they have to intersect in a line, right? Two planes cannot intersect in a point. So it was key to
Mhm.
knowing that. So in order to figure out how to write that line in terms of K, you had to, like you would with other problems, eliminate one of the variables. So Devin, tell me again give me your ordered triple, and I'm gonna write it down and then I'll help you with part B.
Okay, so I had 10x
Yeah?
plus 4y
Okay.
plus 2z.
Oh, is this how you're getting your triple?
Yeah.
Okay, so let's go. So you multiplied. So how are you getting what you're telling me? Did you multiply one of the problems by a
Yeah,
number?
I multiplied 5x plus 2y plus z by 2, and then I added it to 3x plus y minus 2z to isolate the x and the y.
Okay, so it should be 10x plus 4y plus 2z, right?
Yeah,
Uh,
equals
e-
8.
okay, and you added that to 3x plus y minus 2z equals 3. Okay. And then you
Yeah.
got 13x. Yeah, admittedly, you didn't get the best of numbers, but that's okay. So yours is
Mhm.
going to be a little bit messier. Um, but who's to know? You won't know this until you do it. Okay, so then which variable did you choose to solve for here?
Yeah, I solved for x, so I did
Okay.
13x equals 11 minus 5y.
Okay, so 11 minus 5y over 13 was your x, right?
Yeah, exactly.
Okay, so y would be k, and then you'd have 11/13 minus 5/13 k for y. No, sorry, for X, sorry. Um, and then you had to find Z, right?
Yeah.
Okay, and what did you get for that?
I got negative 4k
Okay.
plus 8 over 2.
Okay, so I could rewrite that as negative 2k plus 4, right?
Oh, so you just put every term individually.
Well, if I could simplify it, I do sometimes just to make it easier. You don't have to do that. You could have kept it like you kept it. Um,
Mhm.
so assuming that's right, like I didn't solve for Z here, but your question is how from that can you find the third plane?
Yeah.
Okay, so just like we've done in the past when you've had to come up with your own system, pick any coefficient you want for X and Z, and then let's figure out what the coefficient of Y is to make it work. Why do you think I'm saving the coefficient of Y for last?
Because then you can like figure out how to like balance out the equation.
Yeah, exactly. So to make life easy, why not just make the coefficient of X 13? Why do you think I'm saying that?
Oh, because it'll just cancel out.
The denominator at least, so I don't have to deal with that. And
Yeah.
pick anything for the coefficient of Z then. What do you want the coefficient of Z to be?
Why don't we do 1?
Yeah, perfect. I would have said the same. Okay, so if that's the case, then I'd have, so 13 times 11 over 13 minus 5 over 13k. And then we're trying to figure out what the coefficient of y is, right? And then we know
Mhm.
z is just negative 2k plus 4. All right, so doing this out here, maybe I'll change the color. I get 11 minus 5k minus 2k plus 4. So what does that mean? In order for the k's to cancel, what should my coefficient of y be?
7.
Yep. And then my constant would be,
15.
yep. So that's what you do. So save, yeah, you just picked one that wasn't that pretty in terms of some of the coefficients in the for k, but you could still find your third plane.
Okay, got it. Thank you.
Yeah. And I believe me, when I do this, I solve for kind of in terms of part A, like for a test. If I were to ask something, I make sure I solve all different versions, depending on all the different possibilities people could eliminate. So it's easy for me to check. Okay, Liam, go for it.
On 2.7 for like the wrap up, on number 10, I was just confused on like how to start that problem.
10. This was the, yes, okay. Let me scroll up. My iPad's slow for scrolling up, so sorry. Oh, this was just a sign analysis problem, right? So
Okay.
I'm not expecting people to find, although some people did, and you might have had success if you did this, if people found or estimated the equations of each of these graphs, but I was not expecting that at all. Instead, because we're multiplying or dividing all these equations together, we're really concerned about where they change sign. And remember, on a sign chart, you always put where the numerator and denominator equals 0. So thinking
Yeah.
about that, where does f of x equal 0?
Um, at 4.
Yep,
X
so I know
equals 4.
that's going to be on my sign chart. Where does g of x equal 0?
Negative 1.
Yep. Where does h of x equal 0?
7.
Yep, and so I'm going to fill in all those circles since it's a greater than or equal to problem. So I'll fill all those in. And then the denominator is 0 whenever k of x is 0. So where is that 0?
Um, K of X is 0 at 5.
All right, I'm actually going to switch so I get myself a little bit room here. Um, so 5, so that's going to be open circle then. Okay, so that's kind of all the places where the numerator and denominator equals 0. And then since you're multiplying or dividing all these functions together, kind of I think of the sign of all of them multiplied and divided. So I went function by function and I said, okay, let's look at k of x. And k of x is actually always positive. So in every single interval, it would be positive. Then I
So
go,
would you have a
oh, sorry, go
square
ahead.
there?
What's that?
Oh, sorry. So would you do like a square there for that particular like k of x squared?
No, you don't need to do that because it actually doesn't even because you're not building a new equation or anything. You're
Okay.
just literally figuring out where this function, which involves all these things multiplied together, are positive. So I don't even care if it's to the squared or not. I'm just kind of looking at the sign of the function in each interval. And then h of x would be negative until I get to 7, and then it becomes
Mhm.
positive. G of x is always negative, except of course when it's 0. And then f of x would be negative until 4, and then it switches to positive. So then again, because they're all multiplied and divided together, I can look at, okay, for less than -1, it's positive times negative, 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 which would result in a negative. And you do that for each of these intervals here, just taking into account all those different signs. And then you go back
Mhm.
to inequality and you want where it's positive.
Okay.
And so one thing that people tended to forget, even if they got this process right, is don't forget, and this holds true for any sign analysis. Remember, if it's a filled in circle, it needs to be included, even if on either side it's not included. So don't forget the -1 in this case, and then 4 to 5, but we got to break up the 5, and 5 to 7.
Okay. Thank you.
You're welcome. All right, Ryan, you're up.
I also had a question about 2.7, the unit wrap up, but this one was about question 17.
Near the end. Is that the triangle?
Yeah.
Yes. All right. Go for it.
So I figured out how to do the first part of it, like when
Yeah.
it goes from B to C, but then I was just struggling on how to write it from C to A.
Yeah. Okay. So let's from the first, like, let me just fill in a few things. So it's 4, I'll try to fill it in quickly. And what would the height of this piece be? This first piece, if the distance would be a rate of 4 times time being t, how do you get back to what the height is?
I believe um, the height was just 6.
Oh, that's
And then
this one. But how about the height of the height of this shaded triangle? Because remember, we're gonna do
oh,
area.
yeah, the height of that shade triangle would just be 2t.
Right, because if the hypotenuse is 4t, opposite 30 will be half of that. So right, that'll be 2t. Let's fill in a few other things. You said the distance from C to AB is 6. And then we know then this would be 6. This would be, I'm just filling in the different distances, 6 root 2. And then on the other side, this would be 12, right? And 6 root 3.
Yeah.
And then let's also put in the times on this side. So to go from B to C, what would be the time there?
3 seconds.
Yep, because the distance divided by that rate of 4. And then from C to A, the time would be, we have to divide it by 4, right? 3
Yeah.
halves root 2.
Yeah.
Okay, and then great. So we got both times. Okay, so tell me what you got for the area for the first piece.
For the first piece, I believe I got 6 plus 6 root 3
Yep,
over 2 or 1/2 times,
yep,
and times 2t.
great. Yes, times the height. Great. And so that was between 0 and 3 seconds. Great. And so the next piece is going to be from, oops, greater than 3 seconds to 3 plus 3 halves root 2 seconds, or 3 root 2 over 2.
Yeah.
Okay. So I'm going to draw what this looks like a little bit. So Here's how I always do it, and I think I've said this before, is I like to figure out first what this distance is. I like to do total distance traveled minus the distance that is passed. So so actually let's first do 1/2, the base. Still the base is the same, so that part's the same. But then total distance this point travels will be 12 plus 6 root 2. But how do I capture how much has already passed? Like, how do I capture this?
Do we subtract 3t?
Yeah, or not, instead of 3t, it's rate times time, which is 4t.
Oh.
Right, because you want to do the total distance traveled minus the distance it's already traveled, which would be the rate times time. But that just gives you this green little piece, but that's not the height. How do I get from this green piece to the height at any moment in time?
Do we put it over root 2?
Yes, right. To go from the hypotenuse to the height, or to one of the legs in a 45, 45, 90, you got to divide by root 2. Right. So that's how I like to do it. I'd like to do the total distance traveled minus the distance that the whole total distance it will travel minus the distance that it has already traveled. The other way people like to do it, which I feel like, Ryan, you've done this way in the past, is of course the same 1/2 times the base, but people just working with this side here and saying, okay, let's do 6 root 2 and then minus the rate, which is 4, and then you'd have to do t minus what amount?
T minus 3?
Right, t minus 3. Right, exactly. So you do that whole bit minus, and I'd have to subtract away this right here. That part that it's traveled. So 6 root 2 minus that part that has traveled. And then what do you have to do after that?
Divide by root 2?
Then you'd have to divide by root 2, right? And do you see how that's the same thing as the thing above?
Yeah.
Yeah, so that's the other way to do it. Some people like to, I don't know why I always do total distance minus the distance that it's already traveled, but I just kind of go about it that way. The thing that usually people forget is to divide to get the height. Okay, is that helpful?
Yeah, thank you.
You're welcome. Jackson. Oh, and then I'll do Logan. Sorry, I might have missed Logan there. Jackson.
So I have a question from like the most recent quiz
Yeah.
for number 2. So I was kind of unclear on how to find the range. So I got 1 to 5/4 and then union 5/4 to infinity.
Yes.
But you said it had to be under a square root, and I'm
Yeah,
not really
can
sure
you-
why that is.
Can you tell me the problem again? I actually don't have the quiz in front of me. So
Oh,
what
so
is
f of x
Yep.
equals 2 times the square root of 5x minus 2
Yep.
over 4x plus 1.
Yep.
And then outside of all that, it's just plus 1.
Okay, yeah, so I can answer your question. So first you found that if we didn't have a square root, right? You found that this particular, say this was just the function. You set it equal to k, and what did you find this function could not equal?
5/4.
Right, so you found it couldn't be 5/4, so k cannot be 5/4. Okay, so then if I think about the fact that it's inside a square root, I have inside the square root, the lowest that can come out is 0, right?
Yeah.
Okay, so it can't be negative infinity, and then you just said 5/4 and then 5/4 to infinity. And now if you actually follow the order of operations, what you have to do to everything inside the square root is take the square root of it, right? So it'd be
Yeah.
2 times times 0 square root of 5 over 2, union square root of 5 over 2 to infinity, and then add 1 to each piece. So that's what I mean by you forgot it. You were right, it can't be 5/4, but it can't be 5/4 inside the square root, which means when it comes out of the square root, it can't be root 5 over 2. So then when we do this out, it's 0 to root 5, union root 5 to infinity. I'm just multiplying by 2, and then add 1 to each piece. So root 5 plus 1, union root 5 plus 1 to infinity.
I see. All right. Thank you very much.
You're welcome. All right, Logan.
So I had a question, I think to the same type of problem where it's like a K problem inside of a root.
Yeah.
So for finding the domain is the best way using like sign analysis.
100%. So
Okay.
whenever you see a square root, even before we talked about sign analysis, I wanted you all to get in the habit of literally setting up an inequality, right?
Mhm.
So Logan, you would say whenever you see, like we've only talked about 2 issues with domains we have to worry about. Denominator can't be 0. And when you have an inequality, it has to be greater than or equal to 0. So whenever you see an inequality, the first thing I would set up and write on your paper is the inequality. Because now that we've done sign analysis, we take care of not only the fact that it's in a square root, but we're also going to take care of the fact that the denominator can't be 0 by setting up this inequality and doing sign analysis.
Yeah, okay, perfect. That makes sense. And I just had one other small question.
Yeah.
So wait, I took notes during our class, like our wrap-up class where we went over all of the topics. And then one of my notes under systems of equations were other systems slash nonlinear equations with 2 equations and 2 unknowns. And I was
Yeah.
just kind of confused what that meant.
Oh, so let me pull up the worksheet. I think it was just to show you. It was the sheet we did right after the quiz we were just talking about. I'm pretty sure it was 2.4b, but let me double check just to remind you. Yeah, solving some systems. I believe this is it. Yeah, do you remember when we did this worksheet where, I mean, that one's linear,
Yeah.
that example, but when we solved some of these where literally the strategy was elimination. They look kind of complicated, but you're just solving by elimination. And this is 5 was an example of, yeah, it involved also absolute value, but involved those fractional exponents. So that was the other type of systems we worked with. They're not linear, but you solve them, can still solve them with the knowledge we have.
Okay, perfect. Thank you.
Yep. Ishu, you're back up.
Yep. So on packet 2.7b,
Yep.
there are some absolute value equations where there's like you're supposed to write like the absolute value equation in terms of in like a piecewise notation.
Yes.
But for example, number 1, there's like an absolute value within an absolute value.
Yeah.
How would you go about that?
Oh, this is one where you do it like I think didn't I have one on 2.7 too? Like or no, 2.6b. And I think on
Yeah.
2.7c. I like to go about it in 2 stages, whereas the first stage is to rewrite the absolute value by anything that's alone, not an absolute value and an absolute value, and with the inner absolute value. So I would do that first. So you'd have 3 cases, and you'll still have the outer absolute value here. But then, so you'll have a piecewise function in this case with 3 separate cases. But again, you'll still have that outer absolute value. So then you have to do it again and see if you need to break it down into further subgroups.
So once we solve that simple, like with the turning points of just 11 over 5 and then 9, we would use that piecewise function to then create another piecewise function using the new turning point that's given to
Yes,
us?
exactly. Yes.
Okay,
Yeah, so
great.
try that and see. Yeah, those are good to practice. I think again they've appeared in a few places.
Oh, yeah, these problems will be on the test, or
They definitely could be on the test.
great. Thank you.
Yep. Rafe.
I had a question from the quiz, so I can tell it to you.
Okay.
It's about finding the inverse of piecewise function.
Yep. Okay.
So it's f of x equals x minus 1 in parentheses squared plus 3
Yep.
for x is less than 1, and then negative 2x plus 4 for x is greater than or equal to 1.
Right.
And then
Okay.
it's find the inverse. So,
Yeah, so find the inverse. And how do you feel about graphing these types of things?
I felt pretty good at it. And I just, yeah.
Okay,
pretty
so
good. I
the
just had a question.
graphing part is you always plug in the restriction, whether it's defined there or not. So here we would have plugged in 1 and the output would have been 3, right? And
Yeah.
normally that would be an open circle here. Well, it is an open circle, but it might get filled in. We'll see if it gets filled in by the other. And then I'm going to plug in something like 0, and that would be 4, just to get an idea. And this is a quadratic that it's not going to be, so you don't want it looking like a line. It should be a curve. And then when the other one, when I plug in 1, oh yeah, this one doesn't line up. That's right. I get 2, right? And then if I plug in at 2, it's 0. So maybe I'll just do it. So is that graph okay?
Yeah.
Okay, so then I also like to, especially if I'm finding the inverse, I will just mark the range for each piece. So this top piece had a range. The y values were greater than 3. So I'm going to need that when I find the inverse. And this one, the y values were less than or equal to 2. So I just, again, like to do that because you're going to need it for the inverse. Okay, so now to find the inverse. So this one actually incorporated some stuff from Unit 1. Because, Rafe, how do you prefer to find the inverse? Do you undo or do you switch x and y?
For this one, I undid.
Okay, so normally with x minus 1 squared, you'd subtract 1, then you square, then you add 3. So to reverse it, I'm going to subtract 3. The opposite of squaring, and this is what we just have to drill into our heads, is either the positive square root or the negative square root. And to determine which it is, I want to look back up at my domain restriction. So it's saying for all values less than 1, which means the range of the inverse is going to be all values less than 1. So if I want a range that's mostly negative, do I want a positive or negative square root?
Negative.
Yes. So that's what, again, drilling into our heads that when we opposite of squaring something is square rooting, and you have to decide either positive or negative, and then add 1. And then the restriction is the range of the original piece. So it'd be for x greater than 3. And then the opposite of the other one's a little easier. So I'm going to subtract 4 and divide by -2, and x less than or equal to 2, the range of the original piece.
Yeah, okay. Thanks.
You're welcome. Liam.
I had a question again, like 2.4b with the absolute value one.
2.4b. Oh, that's the systems of equations one?
Yeah.
Okay.
So once you solve for x, how would you like deal with the absolute value with the 2y minus 5?
Okay, so tell me, tell me 2 things. What did you get for x to the 2/5? And then tell me what you got for x.
I think I got like some like weird answers that weren't right for x yet.
Okay, so let's then not use those. So let's just quickly, how I would approach this is it sounds like if we're getting rid of the absolute value first, I'll multiply this by 3 and this by 4. So I've got 9x to the 2/5 minus 12, 2y minus 5 equals 45. And then 8x to the 2/5 plus 12. And again, I'm getting rid of this absolute value piece equals 8 to 108. Okay, so now I always multiply so I can add and cancel, because when I subtract, for some reason, I always mess up. So 17x to the 2/5 equals 153. Does that look right? 3, 1. Yeah. And I'm guessing how I designed this. This goes in evenly. Anyone know 17? How many times? 9. 9, right? Yeah, 9. Okay, so now, very important, everybody. How you deal with x to the 2/5 is I always rewrite it like this because I want to remember that I'm first taking the square root of both sides. And when I take the square root of both sides, when I'm solving for a variable, what do I have to remember?
Plus or minus.
Yep, plus or minus 3. And then to get x to the first, I'm going to raise both sides to the 5th power. So x is going to be plus or minus 3 to the 5th, which is, why did I always forget that? 243, yeah. Okay, is that all right, that piece, Liam?
Yeah.
Great. And okay, so now the reason I asked you before what x to the 2/5 was, I'm actually not going to plug back in x. It's just easier when I'm solving for the rest of it to plug back in x to the 2/5, right? Because I need x to the 2/5 anyway. So maybe let's plug it into the first one. So 3 times x to the 2/5, which is 9, minus 4, absolute value 2y minus 5 equals 15. So negative 4, 2y minus 5 equals 15 minus 27 is negative 12. So we've got absolute value of 2y minus 5 equals 3.
Okay.
Okay. And so now it changes sign across 5/2, right? So if y is greater than or equal to 5/2, then I've got 2y minus 5 equals 3, or 2y is 8 and y is 4. And
And
is that greater than or
also-
equal to 5/2?
That's greater than, so that would work.
Yep. All right. And the other one is y less than 5/2. I'll have negative 2y plus 5 equals 3, or negative 2y equals negative 2, y equals 1, which is less than 5/2. So it turns
Okay,
out we have 4 answers here. We've got 243, 1, negative 243, 1, and then we've got 243, 4, and negative 243, 4. So those are the 4 answers.
So whenever there's like absolute values, you should be doing cases.
Yep, absolute value, always cases, always, always.
Okay, thank you.
And you're back, Ishu.
Yeah, so for the same problem,
Yes.
or like similar types of problems, could you just replace the x to the power of 2/5 and absolute value of 2y minus 5 with like a simple variable like a and b, and then solve for that equation, and then a and b, and then plug it in at the end, just to get the different.
Yep.
Okay.
Totally. Yes. Yes. Absolutely. Yeah.
And what cases would that like not be suggested? And like
the only time
what
you
would be
couldn't do it,
suggested?
but then again, it would be a completely different type of problem. The reason you can do that is because each equation has the same like variable component, right? You can do that because
Right.
these are the same and then the other two are the same. So you can always do that if that's the case.
Okay, great. Thank
So,
you.
and if that is comfortable for you, totally do that. Some people just get so confused if they start substituting in things that that's not comfortable for them, but if it's comfortable for you, totally.
Because for me, like I feel like having all that, like both the like fractional exponent and then also the absolute value can get a little bit messy.
Yeah.
I don't know if it wasn't as simple as just multiplying the first equation by 3, and the other by 4. Like I don't know.
Yeah, no, you
So
can totally do that. And
great.
we're
Thank
gonna
you.
we're gonna do a lot in this next unit talking about substitution like that with complicated things. So
Great. Thank you.
you're welcome. Well, people think if they have a question, I know there was a question in chat and she can't be at this because of sports. So I wanted to make sure I address this, and other people may have the same question is, what was I getting at? And this is in 27C, 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 number 2. So how, to be continuous means they pieces connect a piecewise function. So you could draw it without lifting up your pencil. So what that actually means is when I plug in the restriction for the first piece in this case, then that should have the same output when I plug in the restriction in the second piece. So what do we get when we plugged in 5 for the output in the first piece? Did people get that output and not 1, 4? Sorry. 1 plus 3 is 4. And so in order for this to be continuous, that means when I plug in 5 for x into the second piece, I should also get 4. So that was the answer to the first part. It was saying, okay, what do I need to happen in order for this to be continuous? And it means in order for the pieces to connect, I need, when I plug in 5 to the second equation, that should also equal 4. So that was the first piece. And then the second piece was, okay, so if I have this first piece, which I'm going to graph as, remember, square root function is slow growth. So when I plug in 5, the output we said was 4, and it's filled in. So looks like this. So this is at 5, 4. And then I've got this line, and I'm asking you about the value of b, which is the y-intercept of the line. And remember what it means to be invertible. It passes the horizontal line test. So the y-intercept of the line, in order to pass that horizontal line test, it has to be less than 4. So that's what you wanted to say for part B. And then I think part C was, yes, part C was then just actually finding the inverse, which we already just talked about how to do. Yes, Ava.
I think you already went over this one, but I just joined in. So could you just go back to the solution for 2.7C number 4?
Which I think is in the same packet. Yes. So it all depends on, like, so they could have had multiple different solutions. The key, though, was you're starting off with 2 planes. 2 planes have to if they're intersecting, it has to intersect in a line. You're not going to have 2 planes that intersect in a point. So knowing that, you are going to eliminate one of the variables, just like you would get, like when we have 3 planes, we'd like to get down to an equation with 2 unknowns, and then we can solve for one variable in terms of another. So Devin here, who was asking me, had solved for, had eliminated z and solved for x, and then wrote k as y and x in terms of that k value. And then, of course, you plug it back in to find the z. So just like you do with the other problems with 3 planes. And then once you have this ordered triple in terms of k, you find your solution just like you would find a third plane, just like you would, in the other problems when I say, here's a solution, find a system. Does that make sense?
Okay, awesome. Thank you. Yeah.
And I solved it. You'll see in my solutions on Canvas that I forget which one I eliminated. Maybe I eliminated Y, but whatever one I eliminated, I ended up not with fractions, which was just a little bit easier when you're writing the ordered triple. But the key is two planes intersect in a line, so you're knowing that you're writing it in terms of K.
Okay, awesome. Thank you.
Jackson.
Sorry, could you go over like how to find like the least common denominator and simplify those complex fractions, like especially for packet like 2.0 and then question 9 part I?
In 2.0, yeah. Let me pull that up. I love complex fractions, but for some reason, I think I must have like in middle school, like beaten fractions to death because I just remember drill after drill of complex fractions in Algebra 1. But I feel like they do it less now. Okay, but it's actually super important, especially you're going to have have them a lot in calculus. And if you don't know how to deal with them, it can be very annoying. Okay. Let's open this up. All right, you said it's towards the end, right?
Yeah, literally the last problem.
Okay. Did you say 9i?
Yeah, 9i.
All right. So negative x minus 2. Okay. So first thing you have to do is whenever you have addition or subtraction, you can't just move things top to bottom here. So we're going to rewrite it as 1 over x plus 1 over y over 1 over x plus y. Right?
Yeah.
Okay. So there are different ways you can deal with this, but how I tend to deal with complex fractions is I look at all the fractions I have out here. So I've got this fraction, and this fraction. And the least common denominator or the least common multiple is what I'm going to multiply the numerator and denominator by. So the only thing that I can do here is x times y times x plus y. That's going to be my least common denominator. Not overly pretty here.
I see.
And so if I went about doing that, so x plus y over xy. And the reason you do that is so that right away you no longer have a complex fraction. So now let's go through, distribute it in the numerator. And when I distribute it, what goes away and what stays?
For x and y go away. And
Well,
then for one of them, yeah.
Yeah, for one of them, right, the x gets eliminated. So it's going to be y times x plus y for the first one, plus x times x plus y, all over xy.
Yes.
And then it's just simplifying. So I would do xy plus y squared plus x squared plus xy all over xy. And then
Oh, I see.
And then I can combine the xy's. There's 2xy plus y squared over xy.
Okay, and then I can just like you can just leave it like that. And
Yeah, there's not,
that's
if there was something a greatest common factor I could take out of the numerator, I would have it, but there's nothing, unfortunately, I can't simplify further. So that you can just leave it like that.
I see. Okay, thank you very much.
You're welcome.
I'm sorry, I just arrived.
Hello.
Yeah. Can we possibly go over piece? I don't know what we've covered, but can we possibly go over piecewise functions with like the triangles?
Yes, so we did the one on 2-7, the last one here. Have you done this one?
Okay. I've done. It's okay if you guys have already done it. I can just watch the video.
Yeah, so you may want to go over and see. Yeah, so I'm gonna put this up, and then you can see how we went about this one, because I go over the two different ways you can do the last part too, so that might be helpful to go over when I post this video, which will be right after this.
Okay, thank you so much.
You're welcome. How are people feeling about this stuff in general? Don't forget how to deal with the different types of inequalities, absolute value problems. I feel like a big thing is just problem identification.
What would you say is the hardest problem or hardest type of problem on the test?
I'm not gonna say.
Okay.
Yeah, I don't know. I'm hoping nothing. I'm actually hoping nothing strikes, because I think it depends, actually, if I'm thinking about it. I think honestly, I don't think it's any given problem, although I can think of one that might be, but I think it's mostly like I found on the last quiz for people, it was identifying what type of problem it was in front of them and just making sure you're good at remembering, okay, what do I do if there's absolute values? Oh, I have to set up the cases. What do I do if it's absolute value inequality? Not only am I setting up the cases, but I got to make sure my solution is the overlap between the case and the solution of the inequality. So it's like little details, I think, that I'm worried about a little bit, that I want to make sure people are good about. What I think is going to be the most annoying for probably you and me is systems of equations problems when people make mistakes, like me going on the hunt to try to find your mistake and you being frustrated because you know you have a mistake but can't figure it out. So my advice there is, if you're going in circles, move on and then come back.
I had a question on kind of like the wild card like questions that you give us, like on like the last one or on the last test, it was like the last page. Like generally, like how do you think we should go about like solving them if we don't get them like immediately? Because I feel like sometimes like if you don't get it immediately, it's kind of like hard to think about.
I love how you called it the wild card. The Wild West. So I tend to like to read the test first. And so if you read kind of what that problem is, I feel like, and then go back and start the test, I feel like it may have come to you. I think you're talking about that transformation with that figure. It may have come to you when you were doing other types of problems that, oh, wait, this is just a function transformation problem. So it may be helpful to glance at the whole test first, particularly one that you think might be tricky, because then you can have that in the back of your mind as you're navigating the easier, more straightforward problems. Does that make sense?
Yeah, I think so. I don't know.
And
I feel like it's
also,
kind of just a matter if I get it or not.
And also think that, I mean, I'm always going to ask you something that's super related, or directly related even to something we've done in the past. It may just look differently. So that's the other thing. It's just, what am I assessing you on? Like on that back problem, oh, it really was about going point by point with the transformation, and how do you go about doing that? And so I would ask yourself, like, what is Miss Jensen asking me, or assessing me on this problem? I actually don't think there's anything on this assessment that's going to trip you up like that, though. At least not whole. Maybe a part might trip you up, but but yeah, so I kind of less worry about it on this test, to be honest. I mean, hopefully, I'm hoping you're seeing that a lot of this stuff, maybe minus the, the triangle stuff, is very procedural. So it's really getting down these procedures and when to do which procedure. So I feel like it's different in that sense. And I also would say how you get good at problem solving like that is just by, when I give you hard problems, doing your best to go as far as you can without looking at my solutions or asking a question. The only way you get good at problem solving is like just practicing, doing as much as you can as if it were on a quiz or test without looking at any resources. You will get better and better at it, but it does take practice.
Okay, that's reassuring. Thank you.
Ryan.
I had a quick question about the quiz.
Yes.
Question 5B. I was just wondering if you could show me, I could just walk through it again.
I can, given I don't have the quiz in front of me. If you could tell me what 5B is, that would help me out.
Yeah, it was the problem where was the absolute value that you couldn't cross multiply?
Oh, right. So can you read it to me what it is?
Yeah. 3 over the absolute value of x minus 3
Mm-hmm.
minus 1.
Yep.
Oh, sorry, the minus 1's in the denominator.
Oh,
after
yeah.
that
Oh, yeah, I remember this. Okay, yep.
is less than or equal to 2 over x minus 3.
Yeah, so the first thing, whenever I see an absolute value, just get into the habit of, you have to rewrite it without an absolute value. So I would just do that first. So there's just one absolute value. So, and it changes sign at 3. The mistake people made was saying like there was, I don't know, a lot of people gave me over 0, but remember, it's whatever, the turning point is wherever inside the absolute value makes it 0. Okay, so if x is less than 3, then I'm going to rewrite this as 3 over negative x plus 3 minus 1. Right? And then, then I can bring things to one side. I can't cross multiply again because I don't know. The denominator could take on values that were positive or negative, which means if I multiply across, I'm assuming positive, so I'll lose solutions. All right, and then common denominators, just the two denominators multiplied together. Minus 2 minus x plus 2 all over negative x plus 2. Someone holler if I make a careless mistake as I'm talking and writing this. Okay, so then quickly in the numerator, we would get 5x minus 13. And then we do our sign chart, right, Ryan? So we'll put where the numerator is 0, which is 13/5, and then where the denominators are 0, which are 3 and 2, open circles. And then first thing I'm going to do is just solve this inequality. And looking at this, if I put in something like 5, I believe it is negative. And then it should change signs across everything. Is that
Isn't
what
13/5 smaller than 3 though?
13/5 is smaller than 3? Yes, thank you. And it was 3 in the bottom, right? Did I do that right? 13/5.
Yeah.
Didn't make a mistake, I don't think, with the top. So 13/5 and then 3. Yeah, thank you. That would be smaller. And then 3 and okay, so sorry, greater than back to greater than 3. Greater than 3 would be negative, right?
Yeah.
And then it switches. And we want less than or equal. So if I was just solving this inequality, I would say 2 to 13/5, and then union 3 to infinity, right? But
Yeah.
I need an overlap with remember, I wrote this assuming that x was less than 3. So what's the only solution that's going to come from this piece?
2 to 13 over 5.
Right, exactly. So that's the solution to this piece. And then you're going to do the same for x greater than or equal to 3. You're going to rewrite it and then get and solve the inequality and get the overlap between the inequality and the restriction.
Okay, thank you.
You're welcome. Sabina?
In 2.5, we talked about the distance formula.
Yes.
This was when we were graphing the 3 dimensions. I feel
Yes.
like we never covered that after. Should we still know about all the
I feel like you should know the distance formula. Yeah, just I mean it's the same in 2D as it is in 3D. It's just that extra variable, right?
Yeah.
Yeah,
What,
that's
what
good.
about how graphs look like in 3D planes?
No, you don't have
Okay.
to know. The only thing really other than the distance formula is knowing the intersections of 3 planes like that we've been doing with systems of equations.
Okay, but we don't need to describe and saying like this is the cone and this is the radius.
No.
Thank you.
I won't ask you that. All right, last one, Liam.
On the quiz for problem 2, it was like find the domain of 2 times like square root of 5x minus 2 over 4x plus 1.
Yes.
So how would I find the range of that after like doing the K problem?
Isn't
where you
that
get, like,
that's the one we did here, right? Did a little bit earlier here, where
yeah.
we found that it couldn't be 5/4, like if you did the K part. And then you go back to the fact that it's a square root, and the smallest coming out that we could have coming out of that square root is 0, or even inside that square root. And then you told me or you would have found that it can't be 5/4, and that I'm looking at this step right here. Like once you analyze the K piece, you put that back into what can come out of that 5x minus 2 over 4x plus 1, which is in a square root. And then you just need to make sure to take the square root of each piece, multiply by 2, and then add 1.
Okay. And then for domain, we should just do a sign chart of
Totally.
5x minus.
Yes, whenever you see an inequality, I'm asking for the domain. Whenever you see a square root and I'm asking for the domain, set up the inequality. Because once you do that, like actually write it down, I'm hoping that'll clue you into, oh, inequalities, we do sign analysis, because that's the point of these.
Yep. Thank you.
All right, everybody, you got this. Get a good night's sleep. I will see you tomorrow. The tutorial room is likely going to be, for those who have it after A block, is going to be taken because I'll have some extra timers in there during tutorial likely. So feel free to study, but you won't be able to come into my room for a tutorial if you're in B and C block. Okay, I'll see you guys tomorrow.
Great, thank you.
Bye.
Ms. Jensen. Thank you, Ms. Jensen.
Thank you, Ms. Jensen.
Thank you,
Have
Ms.
a good
Jensen.
night.
Thank you.
You.
Bye, guys.